of the mappings because I wanted to do it again afresh.
So connect through Informatica system.
Okay, hold on. Let me just get that here.
Do you have any questions? Database or Informatica?
Yeah.
Do you have any questions in a database or Informatica?
No, not as of now. No.
In database also?
No, I had one question actually, and I forgot what it was. It was after okay. I'll get back to you today.
Yeah.
Yeah. I had one question. It was like the command that I just don't know why that command is used. Like, when you split the word, first half of the word, why do you use that? You know what I'm talking about?
I didn't understand. So come again.
Okay. So hold on. Can you give me a second? I'll open my.
Okay.
Page 40, 45. Prasad, why is this commit work command used?
Commit is used to save the database.
But doesn't the database anyway save? Or
For example, if you create the table, you insert number of records, but temporarily. If you want to permanently store the particular records in the database, you have to commit. So whatever the transaction you performed in the database level, so if the modifications in the database, so every modification should be saved by only commit statement. So without commit, you cannot save. That is the
okay. This one I didn't understand. String function.
String function.
Init cap I understand. Lower I understand. Upper I understand.
Okay.
Just this one. Okay, hold on. R trim. Yeah, this was the one. L trim.
R trim.
Yeah, right trim and left trim. I don't know why it is used and what's the point.
Unwanted, it trims unwanted characters. That's it. For example, your name is Ketki. For example, instead of Ketki, star KETKI, that is the name.
Right.
By mistake. Okay. So we have to trim star characters from left side. So you have to take L trim.
Okay.
So that is the reason. That's funny.
Oh. Okay, that wasn't bad. And L pad, left pad and right pad.
Okay. So for example, here the syntax of LPAD, WritePad is you have to take one string and you have to specify the size for that, and you need to specify one more different character to fill the remaining characters. For example, your name should be, the string is Keti, K-E-T-I, total 5 characters. But you assigned total 10 characters for that particular string. So remaining 5 characters, what you want to assign is the specific character. So for example, LPAD means left padding. That means right justification. So LPAD takes, for example, if it is a star character, if you take, so 5 star characters and then Keti, total 10 characters, right?
Mm-hmm.
So that's
Oh, okay. So it basically, like if Ketki is 5 characters
yeah,
and it gives that extra star as padding. Is that what you're
yeah,
saying? Okay.
right. For example, if you take more than 5 characters size, then in this particular situation, so remaining characters needs to take some particular character, just only either star or dollar symbol or any other different character, whatever you specified.
So can we give an example of a check, like when these checks get printed in the banks, your pay to name is written as whatever Ketki, Karachi wala, and then the remaining space, just because you don't want someone to write anything, you give that padding.
Yes, of course. In some cases, for example, in moving the data from one location to another location or one database to another database, so in that cases, you will get some different specific characters. Actually, if you did, for example, in my first example or second class example of Informatica, when we are working on any flat files, different type of flat files, if you are moving the data from source Oracle relational table to flat file, in that particular case, we have a commission column in the source database relational table. So in that particular commission column, there is no data for different columns, for different records. So if it is a null value, then the Informatica provides either star character or any other different character to fill in the flat file level. So in that case, by default, for null characters, for null type of information, for particular column, automatically it stores any different character as we specified, right?
Mm-hmm.
So these type of characters, in some cases, if you concatenate with other different strings, so those are all additional characters. Those are all in our not requirement. So for that case, we have to trim or trim. Okay.
Mm-hmm.
This is one example. Okay. And LPAD, RPAD means actually the size of fixed length character string, right? You know, fixed length character string data.
Mm-hmm.
So if you are using fixed length character string data, by default it takes empty spaces for remaining characters. For example, I take 20 characters is the maximum size for the column, but I entered only 10 to 10 characters. So remaining 10 characters, by default it takes empty spaces, right?
Right.
In this case, instead of the empty spaces, just we can put some different characters by using LPAD or RPAD, these type of functions.
Mm-hmm.
Frozen, mommy. Frozen. No, I'm frozen. Frozen. Mommy, I'm frozen.
Okay.
Next.
Hey Prasad, I have a question for you.
Yeah.
Very sincere question. So when do you think we will finish the training, or the reason I'm asking is I have to travel. So I have to be on the road. So I was just wondering because I don't want to miss any class, when I'm traveling.
Yeah, how many days of traveling?
I am traveling from here to Texas, so that means 4 days. Almost 4 days. 8 hours every day, 28 hours is how much it will take me. So approximately 4 days.
When you plan to travel Texas?
I'm not. 10th of December will be my last date in California. So I'm trying. I'm just trying to move out before that. So I just wanted to know that if we are taking more hours, I am fine with that. And then I can also get some more time to practice than in the daytime.
Mostly we have 15 or 16 days from today onwards. Okay, definitely we can try to finish the course by December 10th. So if not completed, then maybe after traveling also we can take 2 or more 3 classes to finish the course.
No, I
No
mean,
problem.
what I'm trying to do is I'm trying to accommodate that time, in the morning time whenever I will be there, I'll make sure that I be there in the morning time. That's the
Okay.
only thing.
Most probably we can finish the course by December 10th.
Oh, okay. Okay. That sounds good too.
Okay. Preeti, tell me, what's your question?
My question is about firstly, if you can review that aggregate, right? Then I think I will be back on track because I was not sure how to go about that aggregate thing, expression aggregate, and I think it was in that we had the commission, the salary fields, by the way, and I think was it filter?
Wait. Did you try the example or not? First of all,
I did. I tried it, but
just
I
open
tried it. I'm sorry?
Open the tried example.
No, I tried it, but something, it didn't seem to be right, and I ended up undoing the mapping. I deleted it because I wanted to try it again, but I attempted it.
Better if you don't delete, because I don't know how to try it, or what is the problem there. So how can I rectify all those things?
Right.
You delete, how can I analyze? How do you know?
I know.
That's it. Okay, so first of all, you don't know how to implement the transformation of aggregation, right?
I did not. I'm not sure about that. Yes.
Okay, and one more.
It was that class, pretty much what we did on that class. I think we did expression, aggregation, and was it filter? Did we? I think there's one last week.
Filter.
Yes. Yeah, we did those 3 in that one class, and that one I am a little puzzled. So if you could show us how to do them, I will be able to try and be able to understand, I believe, a little better.
Yeah. That is the reason why I'm daily class telling you to try to do practice. Without practice, if I complete the course, no use. Right?
I know. No, yes, I know. It's just that one class I missed. So, if you can review that stuff, right? I think, I tried the rest of the transformations and they actually went correctly than what you see here. And they actually went fine. I got success when running that. I didn't have a problem with, but that one class I didn't have enough information with me, so that's why I was not able to move ahead.
Yeah. The expression transformation example here.
Yeah, can you do it again? From the beginning for the expression transformation.
From the beginning is actually the entire thing is same. So in those import, target importing and creating workflow, creating task, running the workflow, so everything, entire thing is same.
Okay, hang on, Prasad, can you give me a recording permission? Okay.
Yeah, already good.
Okay. fine. I wanted to observe this.
So only the difference between our daily examples is applying the different transformation depends on our requirement only, right? So
Yeah.
rest of things, so importing source table, either creating or importing target table, and creating mapping and creating workflow, creating task, link up the tasks, applying the connections for mapping connections in the session task, and finally running workflow. Everything is same. So same process, step by step, every process is same, but only the difference is applying the transformation depends on our requirement. That's all. Okay, here this is the expression transformation. Mostly, I already told you that expression transformation and aggregator transformation. These both transformations based on the single row and multiple row functions of the database, right? So the expression transformation it supports complete single row functions of the database, and aggregator transformation it supports complete group functions or aggregator functions. Along with this, group by class in the database level. So this is the difference only. So here, actually, by using expression transformation, we convert the data from one format to another format. So, for example, character functions. Character means either uppercase to lowercase or any format to either a specific format, or from character format to number, number to character, character to date, date to character. So whatever the type of your requirement. So we have different type of functions are available in the expression transformation. By using those functions, we can convert the data from one format to another format. So that is the main reason here. So actually here, in my source table, the employee name column completely in uppercase in this example, and job is also in uppercase in this example. But in my target data warehouse table, I want to store this the ename column as a unit cap format and the job column as a lowercase format. So no need to take uppercase here. So for this purpose, I want to convert this from uppercase format to one column unit format, and another one column is in lowercase format. That is the reason here I just take some different additional ports to generate the new values, o_ename and o_job. So for these columns, the expression value should be based on the function we can change. For example, here we have different type of functions are available. When you see in the left panel, so character functions, conversion function, data cleansing, date, encoding, financial, and numerical, scientific, specific. So we have different type of functions are available here. So based on your all these functions, whatever your requirement, we can convert the data from one format to another format. So for example, here we are applying the requirement on character name, ename column. That is the character column. So you have to convert this from uppercase to unit cap format. So for this purpose, we have a different type of function, character. So if you open the character, so we have different type of character functions, ASCII, choose, char, all these. So when you select the function, so automatically the syntax of the function is displayed below. So as per the syntax, we have to specify the format here. And finally, what it returns for each function is here. It returns character concatenated with second character. So this is the concat function. So here the concat function allows two different character strings. It returns character 1 concatenated with character 2. That means, for example, one name is Prasad, one name is Durga. So finally, when you concat these two different strings, Durga Prasad. So this is the output here. Okay.
Yeah.
So these type of different type of functions are available. We can use these functions to generate the required values. Okay. So clearly observe right. So when you, here the job column also is same.
Similar.
So
yes, got that. Got that too.
So whatever your requirement, based on your requirement only you can apply here. Okay. And one more thing, when you are trying to practice, just try to add sal plus commission and just you have to take total salary in the target table. So for this additional total salary column, we can generate with the help of existing salary and commission column. Okay. So by using salary, how will you get the total salary based on the salary and commission column? We can add. So salary plus commission equal to total salary, right?
Yeah, yeah.
So the thing, you can generate the values by salary plus commission, applying some mathematical arithmetic formulas. So by using expression transformation. Okay. So main reason for expression transformation is converting the data from one format to another format and deriving the values to additional columns for the target table from the help of existing column of the source table. So that is a main reason, importance of the expression transformation.
Okay.
Right. And one more thing is aggregator transformation. This one is the aggregator. So this one is the aggregator transformation. So this is also similar of expression, but only the difference is expression transformation supports only single row functions. So single row function can execute each and every source record. For example, if you have 1,000 records in the source table, if you apply the single row function, the function executes 1,000 times for each and every source record. So that is the reason it is a single row function. But here, when you consider the aggregator function, the function at a time evaluates more than one record. So more than one record means, for example, directly if you apply sum of salary from EMP. So sum of salary from EMP means whatever the number of records are available in the source table, for each and every record we have a single salary value. So for example, if you have 100 records, we have 100 salaries. So it directly evaluates 100 values and finally it returns just the total salary of total 100 salaries. Okay.
Yeah.
So that means the sum function evaluates at a time more than one record values. Right? So it is directly applying at a time number of records on the number of records. That is the reason it is a group function of the database level. Aggregator function in the aggregator transformation level. Okay.
Okay.
So along with this aggregator functions, it provides, it supports some other single row functions also. So clearly observe this. So in the previous transformation expression, there is no aggregator folder. Directly of all functions character is the folder, right? So there is no any aggregator. All this addition to, so aggregator is the additional function, but by using the aggregator, so average, count, cost, last, max, minimum, sum, all these are. So returns the sum of values of n. Okay. So this is the importance of the aggregator function. And one more thing is group by. So it supports group by class also. So if you apply the group by column name on the DPT, so actually here in our source table we have different type of number of records. So records means number of persons are working in our company. So we have different type of departments also. So for each department there is some different number of employees. So actually if you want to calculate the sum of salary from whole organization direct without any group, so you can directly apply the sum function on the complete all employees. For example, if you want to calculate the sum of salary for each department means we need to calculate separately for each department. So that is the reason you have to apply the group by column on the DPT number. Based on that only, so the DPT equal values all group. It forms as a group and finally it calculates the sum, max, min, average and count of values from each and every department separately. So that is the reason we have to specify the group by class. Okay. So when you apply here group by class and group functions in the aggregator transformation, So finally, it can provide to target table only aggregator column name and rest of any column along with only aggregator function. So for example, here we have a salary column also. If you try to salary column to target table,
There's no salary.
it will be error. It
Yeah.
doesn't provide the salary value because salary is a normal value. But here, sum of salary, max of salary, min of salary, all these are aggregator function values. It returns by the aggregator function only, right?
Okay.
So in this
Yeah.
case, finally aggregator transformation provides only group by column and remaining other any of the column only applied in the group function. So if you apply any column in the group function, then only the aggregator transformation returns to target. So otherwise it doesn't return. So
Okay.
that is the yeah. Okay. So by using
Yes.
aggregator transformation, you can get aggregation summarized data. So from detailed data, we can get summarized data. Actually, in the transformation techniques, we have one technique is called data aggregation, data cleansing, data scrubbing, data aggregation, and data merging. We have 4 different types of techniques,
Yeah.
right? Data cleansing means non-unique format to unique format. So by using expression transformation, we can get the unique format data from non-unique format. We can easily convert the data from non-unique to unique, right? So
Yeah.
you can apply the uppercase, lowercase, all those different type of functions. So whatever the source available format, by using these available functions of the expression transformation, we can convert it into unique format, right? So, so if this is a data cleansing concept. Data scrubbing means deriving the new values with the help of existing values. That particular logic also we can execute through expression transformation. For example, we have a salary column and a commission column in the source table, and we want to take one more column, total salary, in the target table. For this total salary, there is no data from source. We have to derive the value for this total salary column with the help of source existing salary and the commission column. So we can apply it through expression transformation. In this particular expression transformation, we can calculate the salary plus commission and finally load them to target table. So this is the data scrubbing concept. And data aggregation means deriving summarized data from detailed information. It returns summarized data from detailed information by using some aggregation functions only. So by using aggregation means sum, average, min, max, count, all these are aggregator functions. So with this help of aggregator functions, we can get summarized data from source detailed data. So that example should be depends on the aggregator transformation.
Right.
Understand?
Yeah. Yeah.
And one more thing is data merging. Merging means just combining information from multiple tables to single table. So that means actually it depends on source available information, source available tables. We can classify into 2 different types. For example, these are all, one is non-similar structure and another one is similar structure. If the source available tables are non-similar structure, then we have to use joiners to combine the data. If the source available tables are in similar structure, then we have to use unions to combine the data. So that is the difference between two things. Okay, so we already completed these 4 types of techniques, right? Yeah. Next, any doubts?
No.
Any doubts?
No.
Okay, shall we continue to the next topic?
Yeah.
Okay. And next transformation is sequence generated transformation. So clearly, do you know the sequence in the database level? Sequence object in the database level. Sequence object. Any of you?
Yeah, it creates
Exactly.
multiple sequences, right? For the particular, like As
for a particular primary key column, right?
right.
So sequence values means it generates the value sequence, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All these are sequence values, right? So sequence means it generates primary key values. Primary key values means what? So primary key means it doesn't support any duplicate and null values. It supports only unique and not null values. For example, the sequence provides 1, 2, 3, 4, 5, 6 and so on this. Did you find any duplicate value here or else any null value here? No.
No.
So that is the reason why the sequence is mainly used to store the information for primary key values of the target table, data warehouse tables. So in this case, actually, we already discussed in the data warehouse concepts. For example, if you want to maintain complete historical and current information in the target database table, so if you want to maintain complete historical information, you need to follow some different kind of rules. So those are all from source primary key should not be a primary key in the target warehouse table, because if you want to try to insert the duplicate information, and for example, if you want to insert historical information, the primary key value should be same value. So because in our source table, primary key doesn't change. Remaining non-key columns only anytime can update. So based on that, if you try to insert any duplicate value in that particular table, in the target table, if the source column and target table column both are primary key same, so then it doesn't allow. So the particular record should be rejected by the primary key constraint of the target data warehouse table. So that is the reason we need to specify the source primary key should not be a primary key in the target table. But here actually in the relational database management system, we have to take at least one primary key column in each and every relational database table to identify uniquely in each and every record in that particular table. So that is the reason we have to create one additional column, SID. This SID column is we need to treat as a primary key. So by using this SID, we can easily uniquely identify the each and every historical record in the target table. So for this purpose, so most probably we completely complete historical and current information we can store in dimensional tables of the data warehouse schema. So in that particular dimensional tables, we need to take SID column for each and every table. So SID is a surrogate identification column in the target. So for this purpose, we have to provide the values through the sequence generated transformation for this SID column. So that is the reason the importance of this sequence generated transformation is used to mainly generate complete primary key values for that particular column. That's it. Okay. Yeah, actually, in our source table we have EMP, but I want to generate design and generate new table in the target. So here clearly observe the same structure of the EMP. In addition to this, I want to take one SID column. So sequence generated transformation. Here I want to take one additional column. So this is first column. So that is I want to move this to upper SID. So this is a numeric type column. So number. Okay. Just apply and okay. So design is completed. I want to generate and execute. Connect. SR. Okay, so create table. So table is created, source and target both are ready. I want to create one mapping. Map underscore EMP underscore sequence generator transformation. Just okay. From source EMP and from target sequence generator transformation. Here, I want to create the sequence generator transformation here. So actually, without any changes, I want to move all columns from source to target. So just clearly observe the difference here. I am connecting complete total 8 columns to target table, 8 columns, but I want to connect SID column. I want to provide the data for the SID column additionally. So for SID column only we need to take the data from sequence generator transformation. That is the purpose. We need to create sequence generator transformation here. So 1, 2, 3. This is the symbol for sequence generator transformation. Just click here. So clearly observe here, when you create the sequence generator transformation, it automatically creates next val and curve val. These are the two different default ports of the sequence generator transformation. So we already discussed about this actually in the rank transformation also. It provides default port rank index. So whatever the transformation, when you create the transformation, by default it provides any default ports through the particular transformation. We don't want to provide the value for those transformations, for those particular ports. So the transformation itself only responsible to provide the generate the information and provide the data to target particular column through particular different ports. So that is the reason we don't need to take anything. Here just we have to just connect it next val to SID. That is only thing. So clearly observe here ports. So this is default ports. That's the reason we cannot update here. And properties. So start value. For example, if you want to consider one different sequence, so we have to specify the values, start value and increment by value and max value, all these are. So here by default the start value is 0, but if you want to take it as a 1, so we can specify this. And increment by, so we can use increment by 1 also. For example, initially if you call this particular sequence generator transformation, it provides the start value 1. So for second record, if you take the data from this transformation, the current value of the transformation is 1. So increment by 1. So 1 plus 1 equal to 2. So for second record, it provides 2. So the current value is 2. If you want to insert the third record, so 2 plus increment by value 1. So 2 plus 1, 3. So that is the reason it always increments by 1 for current value, and it generates new value. The generated value is provided to target particular SID column. So in this case, if it is a start with 1 and increment by 1, so 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1, 5. So likewise 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on infinity. So the maximum value, basically it provides this. This is the maximum value. Okay. So this is the maximum value. For example, if you don't want to take this maximum value, so in this purpose, for example, right. Okay, 30. So 30 is the maximum value I am specifying. The current value default 1. No need to change this. And cycle. Cycle means, for example, I just take 30 is the maximum value, end value. But in our source database, I have more than 30 records. When you run the mapping, so automatically more than 30 records, all the available records are moved from source to target. So in this case, the sequence generator transformation can generate only 1 to 30. So for example, if the more than 30th record is coming from source to target, so it needs to increment again. So the transformation needs to increment the value again. So but the maximum value is already reached. So for this purpose here, if you take cycle option, then it can start the incrementation from again first. 1, 2, 3, 4, 5, 6 until 30. After 30, it goes to 1, 2, 3, 4, 5, 6 again.
It's like a loop, right?
Yeah, that is a rotation method. And number of cached values by default 0. The 0 means actually for example, if you specify any 10 is the number of cached value. So by default, it at a time automatically generates 10 next values. So 10 next values and store it in a cache directory. So from cache directory only it takes the value and provides to target column. So that is the reason. So only the difference is time taking process. Actually, if you take number of cached values, it generates the particular number of values at a time easily. So the cache, from the cache, the transformation taking the information is very speedy. So for example, if you didn't specify any number of cached values is equal to 0, so the problem is it needs to calculate each and every time when the record comes from source to target. So calculation means it takes some time to generate new value. So that means it takes some time means it will, for example, if you want to load 1 crore records, definitely the lot of difference between without cached values and with cached values, for example, at least 15-20 minutes, the difference. So for this purpose, we need to take to improve the performance of the sequence generator transformation. You need to take number of cached values. So depends on the source available records. That is the difference only. Okay. Just observe this. I just specify all the values. Right. So mapping is completed. So mapping completed means we need to create workflow and task. We have to run this. Right. I want to create here. This is the different task. So this is the mapping. Source sequence generator. Right. Session is created. HTTP specific link and mapping. Source system source target plus our target. Right. Okay. Right. If you want to start this particular task only, then just select that and right click start task.
Yes, sir, that you connected from, that's rank, or what is that session? The one that you connected from?
Connection means?
If you go back to the session window, the window where you created a session.
Yeah, this is the session window.
The diagram, the link you got it from, what is that session? The S_map_emp. Yes, that one, rank. That's what I thought. Okay, that's clear.
Okay. So one after one, actually in the previous classes we created this. Okay.
I know. Yeah.
This class actually creating each and every example workflow creation separately means it takes some time. So that's the reason I'm creating this here. Okay.
That's fine.
So succeeded. So this is the output here. See, actually in my source database I have totally 15 records. So for these 15 records, so clearly observe the SID column only. So initially, if you insert the record from source to target, the first record value is 1 because the sequence generator transformations start with value is 1. So that is the reason. So increment by 1, that means 1, 2, 3. Each and every value, the difference of each and every two values is 1 only. So 1, 2, 3, 4. Actually, we have total 15 records. So actually here, the current transformation sequence generated transformations current value is right now 15 because it generates the value up to 15. So right now the current value is 15. Okay. So clearly observe. I'm trying to rerun this. Mail. Get session log. Cattle transformation error. The sequence generator transformation has reached the end of the configured end value. So did you observe the error here? Actually, I take 30 is the maximum value. Okay, so the transformation already reached to maximum value. So that is the reason it is giving some error. Understand? For example, here transformation, if you select the cycle, how it is actually. And one more example is union transformation. So actually, just a few minutes back, we already discussed how to combine the data from source multiple tables. So for non-similar structures, we are using joiner, and for similar structure tables, we are using unions. So for this purpose, we already discussed about the joiners. So here, the next example is union transformation. So clearly observe this. I'm trying to import the same similar source tables, flat files. Sources import from flat file. See. Either Prasad here. Okay. Product. Import field name from first line. Finish. And one more file. Import from file. Customer. Like, see. So just clearly observe these two different files. Actually, these both are in similar structure. Similar structure in the sense equal number of columns and corresponding column data types are same. So column names are different, table name is different, database type is different, and size of each column is different. No problem. So similar structure means the number of columns and corresponding column data types. That's it. So here four different columns in each table, 4 different columns. And for each table, 2 number type columns, 2 string character type columns. For each table, same. But of course, the difference is size of the column. So for second column, here 7 characters and 5 characters. Here 10 and 7 characters. And here 4 and 6 characters. But not a problem here. So we need to just consider only number of columns and corresponding column data types. These two only. Okay. So these two are in similar structure. So if the tables are in similar structure, we need to use union transformation to combine the source tables and load it into target. Okay. So clearly observe. I want to import one more target table here. So, but actually, if you want to design the new different target table for storing this combined information, you have to take the additional column. Sorry, you have to take additional size for each and every column. So based on size of source both tables, the maximum size, whatever the table column, the maximum size you need to take here. Because for example, if you take a target table column, second column as a 5 characters, but it doesn't allow any more than 5 characters name. For example, if you take the target column, third column as a 10 characters or else it is 7 characters, but it doesn't allow any more than 7 characters. So that is the reason there is some confliction here. So for this purpose, you need to design separately. But here, the each and every column size should be the maximum value of the source available both columns. So that is what you have to understand here. Okay, so for this purpose, in my database already I have one SQL observe. Yeah. Okay, this is the file. Okay, so clearly observe this. Here, this is your target table. Source and targets both are ready. Now I want to create one mapping. Create mapping. Map underscore union transformation. So for this, from the source table, customer and product. From the target, customer 1. So that is the so clearly understand here. I am creating union transformation to combine these two. So this is the union transformation. This is what different. Actually, in our FLS example, we already discussed about rotor transformation. By using rotor transformation, we can allow the data from single source and we can provide the data to multiple targets. So for this purpose, we created one input group and multiple output groups in the rotor transformation. So this is the difference. Actually, the union transformation allows information from source multiple tables and it provides the data to single target table. So for this purpose here, the union transformation needs to take multiple input groups and single output group. So multiple input groups means we have two different source tables. That's the reason we need to create two different input groups and we have to provide single output groups. That is the reason we need to take the column here. So clear observe. I'm taking this from first the customer table. So if you copy from source to union transformation, it automatically split into two different groups, input and new group. So you have to add one more group. So for this purpose, I added here. So from here, just from select second, so just copy this. Clearly observe, actually, source number of columns to size and target number of column size. We have to take more. So clearly, from second table, cost column, 6 characters. But here, 8 characters. So that is the purpose. You have to increase the size of the column. So, clearly observe this. From output group, we need to connect it to target. That's completed. Yeah. You can create a union transformation.
Link.
Edit, mapping. So flat file. So that is the reason we have to specify source file directory. So this is in E drive. That's all. And second is also E drive. That's all. And target. Left drive. That's all. All that. Save. Start task. Yeah. Succeeded. So this copy data. So first of all, I can show the information from here only. So clearly observe, I'm trying to show the four files. So this is the product file, and this is the customer file. These two, clearly observe. The four different CID, CNAME, address, salary, and PID, PNAME, company, cost. Okay, so these are the two different tables. The information is like this. So number, character, all this, and coming to target. Left drive, Prasad, and this is the total 8 records. Actually, from source 2 tables, from each table, 4 records are there. So here, total 8 records. Understand? Any doubts?
No, not yet.
Okay. And one more example. Normalizer transformation. Clearly observe this. Actually, normalizer is used in different ways. One is to get the data from COBOL, and the normalizer transformation is used to convert the information from multiple column format to multiple row format. So clearly, first of all, here student. So the student table, clearly understand this. Here student number, student name, address, fee 1, fee 2, fee 3, fee 4. So actually the fee column should divide it into 4 parts actually. Actually in real time in any college or school if you consider, so the total fee of the annual it divides into 4 different parts. First term, second term, third term, and fourth term. For example, first quarter, second quarter, third quarter, and fourth quarter, like this. So the total is for 1,000 plus 2,000 plus 3,000 plus 4,000, total 10,000. So 10,000 fee they divided into 4 different. First term 10,000, second term 2,000, and third term 3,000, fourth term 4,000. So likewise. So actually here, if you consider only fee column, this is in multiple column format. So only fee value we provided in just 4 different columns. But here, we want to move the information from this file to target table, but in our target table, I want to write this as a row format, not in the column format. For example, in my first record, Prasad 101, Prasad Vijayawada, 1000, 2000, 3000, 4000. That is the actual record of the source. But if it is moved to target, the record of availability of the target structure should be the first record. 101 Prasad Vijayawada 1000. 101 Prasad Vijayawada 2000. That is the second record. Again 101 Prasad Vijayawada 3000. That is the third record. 101 Prasad Vijayawada 4000. That is the fourth record. Actually, for each and every record, for each and every person, 101 Prasad Vijayawada, these three values are same. But only the difference is for each and every record, the fee value should be different. So in this case, actually, the fee is available in 4 different columns format in the source level. That means for each and every source table record, we will get 4 different records in the target. So here actually 3 records are available in source. So 3 into 4 equal to 12 records are available in target. So that is the thing here. So actually the normalizer transformation mostly used in 2 different methods. Actually one is to get the information from COBOL. So COBOL language is different. And one more example is this one. Multiple column format to multiple row format conversion. So actually in this case, clearly understand, if your source database should be mainframes, if your sources at database should be mainframes, then the most common language is used in the mainframes is COBOL always. So of course the COBOL is oldest language. Before C language, Pascal. Before Pascal, we have COBOL. So almost in the 1970s or 1960s, end of 1960s. So those days, they developed one COBOL language. So that old language is still used in the mainframes actually. As a Informatica developer, we don't need to learn the COBOL language, and we don't need to analyze the logic of the COBOL language. But if you want to work on COBOL language, you have to compile the COBOL programming code. So that is the reason. So without any knowledge, we cannot compile, we cannot debug. So that's the reason here. The main problem is there is no COBOL in the market actually. Only mainframes users only using the particular COBOL language. So that is the reason. If you want to work on any source mainframes database, actually there is a different team in real time. The team completely belongs to export the information from COBOL to flat files. So if they export the information from COBOL to flat files, then we can import those information from flat files to Informatica, and we can convert this as a required warehouse format. Finally, we can load to any other source different database. So because there is some little bit difficulty to work on any source mainframe information or target mainframes. Whatever, if the mainframes is the source or target, then we need to export to flat file, and we need to import from flat file to COBOL mainframes. So that is the reason here there is no working on mainframes source or mainframes target in the Informatica. So clearly observe this. This is my second example here. So multiple column format to multiple row format. That's what we need to convert. Source. I want to import the source table here. Source import from flat file. D drive Prasad. Student is the file name. Import from fields. Right. Clearly observe this. The file is imported. Now, depends on our requirement, we have to design new target table here, because the target table should be completely different from source table actually. Because in our source table there are number of columns, but in our target table there is no particular number of columns for fee column. Just we need to take one single fee column in the target. So that's the reason here. So clearly observe, go to targets menu, create target, here target name. Student normalizer is the table name, Oracle is the database, create and done. Here I want to specify the column names. So here clearly observe, S number, S name and address, these are all same columns, but instead of these 4 fee columns we need to take 1 fee only. So S number, S name and address. So in the columns tab, just we need to take 4 columns. One is S number, S name, address, and this one is fee. S number is a numeric type and fee is also numeric type. S name and address both character type. So table is designed as Oracle. Generate and execute. So table is created here. Actually, I want to create one mapping. Map student normalizer. So here student is the source table and student normalizer is the target table. So clearly observe here. So a small magic. This is the normalizer transformation just created here. So this is not the similar transformation with other transformations actually. So up to last example, just we create the transformation, we copy the columns from source to target, source to this particular transformation. So like the same way here, we also want to copy. If you try to copy, you will get some error.
You cannot copy.
Copy a column. So for this purpose here, we need to create the different number of columns here based on the source and target structures. So here the problem is from source, one record is came to normalizer transformation, depends on multiple fee columns. It provides multiple records. That means here normalizer transformation from this example takes only 3 records from the table, source table, but it provides total 12 records to target table. That means each and every single record from source, it provides 12 records to target. So that is the reason here you have to create the different number of ports in the normalizer transformation based on the target and source available columns. So clearly observe, I am editing this. If you want to create any different number of ports, or if you want to delete any ports, existing ports, you need to go to only ports tab. Here we open the ports tab, but there is no icons or enable. All are disabled. So disable means we cannot create any port in the ports tab. We can create only in the normalizer tab. That's the reason. Just open the normalizer. Here create 4 different columns only, because we need to provide 4 different columns to target. So because that is the reason here. First column is S number, second column S name, third column address, and fourth column P. See, these 2 are character type. And one more property you need to identify here, occurs. column name, level, and third one occurs. So here, fourth column, it occurs 4 times from the source. That's the reason we need to specify field 4 times. Just apply OK. When you click on OK, the 4 created columns is divided as this. Up to here, these are all from beginning to up to here, these are all input ports. From here to here, these are all output ports. Okay, so here you can connect all this, and from here we can connect to target. And GK underscore fee, GC8 underscore fee, these two are useful to implement the logic here. Actually, from source, one record is came to normalizer transmission. Normalizer transmission needs to provide 4 records to target table. So for this purpose, from each and every target record, it provides the new value. For example, for first record P1, second record P2, for third record P3, and for fourth record P4. So that is the reason these are the supporting variables to provide the information to target. So that is completed. Just save in workflow here. I want to create one more task, normalizer, and link it here. Mapping source, that is mapping new drive Prasad folder, new drive Prasad folder, and object should be Prasad target. See, start task. Now succeeded. So let's click on the data. See, so 101, 101, 101, 101. Up to here, this is the source first single record. 102, 102, 102, 102. This is the second record, and 102. This is third record. So for each and every source record, we just got 4 records here. So totally 12 records. So for each and every source record, clear up the 1000, 2000, 3000, 4000, the fee values. But here in the source, in the same record, 10,000, 1000, 2000, 3, 4, these 4 are 4 different column values. So that is the difference. Okay. So from multiple column format to multiple row format, we converted the data by using normalizer transformation. Complete. Okay, I started the class today here. So just practice by tomorrow all these examples. So we'll discuss new topics tomorrow.
Okay.
Stop the recording.
1 second.
Any doubts? Any doubts?
No, not until we practice, right?
Yeah.
Okay, then. See you tomorrow.
Yeah.
Prasad, can you
Yeah.
help me out with this one thing request from before? That can you clear my transformations so that I can redo my work? Can you just help me or show me how to clear my old transformations? Whatever you see on my screen, right? I think do you have access to a screen share?
From your?
Yeah, my screen share. Do you have? Hold on. You know what? Let me just close out of this window.
Yeah.
Show my screen. Show my screen. I just want to just remove my transformations, and I'm going to do them again from the beginning. I want to just have a clean info my Power Center. I just don't want any of that. I want to do it from the beginning and, you know.
Don't expand, just open here. So if you
Okay.
expand, clearly observe this. This is in bold and this is in thick. Okay,
Yeah.
that is the difference. You have to open. Then only all the different type of transformation, all the tools are enabled. Otherwise,
No, that is not my question. I know,
yeah.
but I don't want. Okay.
This is your problem, right?
Well, I want to do it from the beginning again. I think it's better if I do it from the scratch properly again. I want to get rid of the existing ones and I'll do it again. I prefer to do it again. That will even increase my practice too.
Okay.
So I just want to remove these mappings. I mean, because simple, a simple right click does not give me any delete option.
Work on practice folder, okay? So work on practice folder.
Okay.
Practice. You have one more folder, right?
Yeah. Practice folder on. Yeah.
If you want to remove this, just simply click on delete.
Okay.
Select and delete.
Okay. Then that's easy. Okay, that's normal. That's fine. I thought I could just do it. Okay.
You don't find any option.
Yeah. That's okay.
Click on delete
That's
button.
fine. Yeah, that's how I was able to do. Never mind. Okay, I just wanted. So I'll just go ahead and delete this 3. Hold on, let me just delete this.
Okay.
I'm just going to delete this few transformations, and this is so manual intensive.
Okay. Yeah, whatever you practice, don't delete actually. If you want to ask some questions from my side, okay. So don't delete, because if you delete, I don't know the problem there, and how can I analyze where you did a mistake. So that is
No, yes. I'm not going to be anyway sharing this with you. I'm going to be starting differently. I mean, I'm going to start it again. And if I'm here, I have removed some in between, so you will not be able to follow either ways. It's better if I re-practice, start from the beginning again, and then in case I have run into a problem, then I can always ask you. But for now, since we're missing out on some files prior to my deletion right now in front of you, there's no point looking at the screen. I want to do it from the beginning so that it's in a flow. I have all my targets in a flow.
Hey Prasad, I have one question. So the data that I created in SQL, I can use it over here also, right, in Informatica? Kate Key.
Yeah. Tell me.
I'm saying that the data I created in SQL, I can use it in Informatica, right?
Yeah, of course.
Okay.
Okay.
Okay then.
Bye.
Yeah.